Welcome to today's math exploration. Have you ever wondered how we can solve complex polynomial problems without diving into messy calculations? Today, we're going to tackle an elegant problem that demonstrates the power of substitution and recursive relationships. Our challenge involves finding the value of a polynomial at a specific point, but with a clever twist that'll save us from unnecessary complexity. Let's start with our problem. We have a polynomial p where p of quantity x squared plus 2x equals x to the sixth power plus x cubed plus 1. We need to find p of -4. Now, here's where things get interesting. Instead of directly plugging in values, we'll use a substitution approach that makes our work much cleaner. Let's call x squared plus 2x simply I. So our function becomes p of t equals x to the sixth plus x cubed plus 1. We need to find p of -4, meaning t equals -4. First, we need to understand what values of x would give us t equals -4. This means solving x squared plus 2x plus 4 equals 0. This is our key equation. Now, let's rearrange this equation. We get x squared equals -2x minus 4. This is our magical formula. It lets us simplify any higher power of x without solving for x directly. Let's see how. To find x cubed, we multiply x by x squared. Using our formula, we get x times quantity -2x minus 4. This simplifies to -2x squared minus 4x. And here's the beautiful part. We can substitute our formula again. X squared equals -2x minus 4. So x cubed equals -2 times quantity -2x minus 4 minus 4x. Simplifying, -2 times -2x gives positive 4x. -2 times -4 gives positive 8. Minus 4x. The terms with x cancel out. We're left with just 8. So x cubed equals 8. Isn't that elegant? Now for x to the sixth power. That's just x cubed squared. So it's 8 squared, which equals 64. Let's put it all together. P of -4 equals x to the sixth plus x cubed plus 1, which equals 64 plus 8 plus 1, giving us 73. And there we have it. P of -4 equals 73. We solved this without ever finding the actual value of x, which would have involved complex numbers. This technique of using substitution and recursion is incredibly powerful. It allows us to sidestep difficult calculations and find elegant pathways to our solution. Next time you face a challenging polynomial problem, remember this approach might just be your secret weapon.